Okay, ladies and gentlemen, our next speaker is Roger Barnes. Roger is an experienced cross-functional software developer specialising in web application development and deployment across the entire application lifecycle. He has run a web development business, been a key driver of internal enterprise deployments at a large enterprise software vendor, co-founded a tech startup in the travel industry, and is currently doing Python-specific contract work. To talk to us about measuring and improving Django application performance, please welcome Roger Barnes.
Thanks, everyone. Hi, and thanks for coming to my talk. As Russell said, I'm going to talk about the life of a web request and how that works in terms of web performance. My name's Roger. You can find me on Twitter, email, and the slides will go up on SlideShare after this at some point. There's a couple of slides full of resources, so feel free, if you don't want to take photos of slides, they'll all be available later. So hopefully, you're here to hear about... Did I skip a slide? Aspects of site performance, basically measuring everything. A very important factor of all this web performance stuff is it's very easy to fix the wrong thing or think you've improved the site performance and you've completely missed some other factor. And I'm going to cover a little bit of how to do this. I'm going to start very high level, and I'm probably not going to go as deep as everyone might want all the way through. So please keep in mind that I'm not going to cover everything on web performance because 20 minutes is not very long to do that. In particular, I'm going to focus more on the user perspective of web performance. So rather than looking at, say, load testing, I'm sorry, I'm not covering that, things like users per server or requests per second, I'm looking more at the user perspective, how the performance of a website looks to them, how long it takes in terms of seconds per request rather than the other way around. So about me, I'm not a psychologist from Victoria. I'm not an actor. I'm not that guy, a footballer, and that's not my mugshot. I'm also not a medical marijuana doctor from Pasadena, but I am a web developer, a software developer. I've been doing this for a long time, and I've always been a full stack in that I've been from conception to delivery of this stuff, which I think is very important. And often in bigger organizations, if you're the web developer and you have a designer and someone else doing infrastructure, it's very easy to forget about the aspects of performance that actually go across all three. So why should we care? Well, it's actually been shown quite consistently over the last few years, and I excuse these badly scaled infographics. Basically, the performance can affect things like engagement, bounce rate, conversion and abandonment rates. Search engine ranking can even be affected. That's now used as a signal in Google search results. And most importantly, the bottom line of all this that is important to a lot of people is, of course, revenue. Amazon, I think, at one point had something like $100,000 revenue difference for 0.1 of a second per day. You'll have to look up the numbers, I'm sorry. I think I got that wrong. On top of that, at the same time, websites and web applications are getting much larger and much more complex. There's more requests, there's more data flying around, there's retina displays, so there's more bandwidth being used for things. All that sort of stuff adds up, and that flies in the face of what we're trying to make faster. For example, HTTP Archive actually keeps track of a lot of this stuff, and as of a couple of weeks ago, the average web page request measured through their system, which actually tracks a whole lot of different websites, was 1.3 megabytes and 85 requests for one web page. Now, some things to keep in mind here is that might be okay. If you only have desktop users and they're only local, so you're in Sydney, you're selling to people in Sydney, and you're hosted in Sydney, that might be okay. So sometimes you need to take into account what that actually means for your users. Users are also increasingly mobile, so now people have devices that aren't as capable as the desktop. They have terrible connections relative to a wired connection. Their expectations at the same time are also higher. So instead of 2 or 3 seconds being okay, sub-second is the kind of thing that people often expect these days. And at the same time, we've got this whole dichotomy of mobile versus desktop editions of websites, and those that are responsive, some of those might look better on those mobile devices, but they're actually downloading the same amount of information, and that can be a huge performance hit in terms of the actual time it takes for it to appear on the screen. So let's have a look at a web request. I've picked at random, well, not at random, I know that there's a Django site in Australia. The person who wrote it might be in the room. I'm not going to say who it is, just in case. And I did this waterfall graph of it. And I came back and I said, 202 milliseconds for the primary request. That's pretty good. It's fast. Maybe it's cached somewhere. I don't know. But in that, first of all, there was a redirect. So I put in the domain name. It said, you need to go to www.domainname. So straight away, we've added a little bit of time. Then, of course, we've got some CSS. So we're pulling down some stuff. One of those is particularly big. And for the home page, chances are you don't need all of that stuff. Now let's get some JavaScript and some images. And 1.6 seconds, which is about 5 or 6 times, more than 6 times the size of our initial little payload, we're actually starting to render the page. Now, if you've got enough to render the page really quickly at this point, then you might come in under 2 seconds and you're okay. In this case, we're actually not done. The whole document took 8.6 seconds, was fully loaded with a bit of extra JavaScript shenanigans at 9, 177 requests, and 2.6 megabytes of data. And this was on a good connection. This is one of those situations where if you were on a mobile device on the other side of the world with latency and everything else, it can take up to 20 seconds for this page to load. Which brings me to my first sort of key point. You might be doing Django web development in your part of the world, but the performance golden rule, as coined by Steve Shooters, is that 80 to 90% of your end user response time is going to be spent on the front end. And that's probably not going to go away based on all the talk that we've had, especially yesterday at Django-con, about the changing nature of web applications. There's a lot more going on the front end. So what that means is we have all these other considerations that aren't necessarily even related to your back-end development. There's latency in database, all kinds of things. So first, as I said, you've got to start measuring. There's a few ways you can do measurement. The first of which are actually real user monitoring type of applications where you are measuring what your users are experiencing. So for that, there's things like Google Analytics will give you some basic timing metrics out of the box. You can also instrument little bits of your front end to actually measure that stuff in your analytics account as well. There's also the commercial offering from New Relic, and there's a free plan as well you can check out, which will give you that, and on top of that, you'll see some back-end stuff if you instrument your actual application. Aside from real user measurement, you've got that idea of synthetic testing, where you're actually running your own tests. You're hitting the web server yourself and you're looking at what's happening. There's heaps of tools available for this, but 3 in particular that I'll mention. Chrome developer tools, also Firebug and the like, and Firefox itself. They give you things like network waterfall graphs. You can look at the timeline of events in the browser. You can even profile it, look at memory usage. This audit tab just gives you a list of stuff that you might want to think about. So from that point of view, it's certainly a good place to start and keep an eye on. Another really good tool is webpagetest.org. This is basically a free service. It's hosted in different mirrors around the world, and you can point it at your website or someone else's website, like I did, from different locations with different browsers, and it will run that test from that location with those parameters, and you can see how it's working. You get a waterfall chart of the first request, of a follow-up request to see how caching and compression and that sort of thing are working. And even at the most basic level, you get a report card which, you may or may not care about some of these things, but at least you get some idea. The third synthetic testing tool you can use is, in modern browsers now, there's a browser navigation timing object in the document object model, or in JavaScript. Now that's accessible through the console if you dig around. More recently, I got this patch put into Django debug toolbar, which will actually pull that data out, and it will, on the client side, add it into the timing panel of the debug toolbar. So you can get a nice sort of snapshot, and this is a contrived example, but you can see how much time is spent relatively on back-end and front-end work. It's not in PyPy yet because there hasn't been a debug toolbar release in a while, but it is in GitHub now. It's actually been put into the main line. So the main front-end offenders we usually find: static resources, just the size and number. As we saw in that waterfall, huge number of resources being loaded. Now the way that browsers pipeline means that that stuff can get queued up, and that's what takes time. The lack of caching and compression, this is very much a web server setting side of things. Third-party resources, all those like buttons and all that other stuff that people put on their websites now, it's usually pretty good in that it's deferred, but it is worth looking at whether that is actually slowing down your user's experience, especially on obscure browsers that might actually not defer when you think it is. And finally, over-downloading. If you do have a responsive site or a tab that doesn't actually get shown up initially, and you're loading that every time, even though most people don't look at it, then you're really just using up time and bandwidth that you don't need. So ways to fix static resources. Minification and combination of your JavaScript and CSS. In Django land, until yesterday, I thought it was Django compressor. Apparently now Django pipeline is the place to look for that. In terms of images, this is all web development 101 stuff, choosing an appropriate format and compression level. One little hack that I came across last year that I hadn't even thought about is if you've got lots of little thumbnails and your thumbnail is actually putting metadata into every image, then there's probably a lot of wasted space in there as well. So you can even eke out a little bit of saved space there by just trimming out, EXIF metadata and things like that that your tools might put in. And finally, sprites are something to consider as well. Furthermore, you can look at your web server and your accelerator. If you're using something like Varnish, you probably already are thinking about performance, so you can always look at the configuration of that. There's a whole world of information out there about caching, compression headers, and that sort of stuff. I don't have time to go through it all today, but if you do want some tips or advice, let me know and I'm happy to help out. Content distribution networks can help. There were some measurements that showed that they don't necessarily help a lot, and in the case of that example earlier, they were using S3 as a CDN, and it was not using any edge point in Sydney, so it was actually slower. You can do things like deferred loading, and there are these other modules called page speed, which will actually work at your web server level and try and grab whatever you send out of your application and mash it all up for you. It might be a bit of a silver bullet, but it might be worth a try for you as well. So supposing you've now mashed together all that front-end information, you've actually got it down to a handful of small CSS, JavaScript, and image requests, and you do want to look at the back-end measurement. Again, in terms of measurement, you've got options like real user monitoring in New Relic. You can instrument very specific parts of your application using that. Some alternatives you can do yourself are things like Django statsd feeding into Graphite. You can instrument very specific parts of your application and see real performance of requests as they happen. You can graph it, you can trend it, you can keep an eye on it. In terms of external individual testing, Django debug toolbar, it's one of the most popular Django third-party add-ons for a reason. It does give you really good information. So in addition to timing, you can look at things like SQL queries that it runs. You can dig really deep with that. You can look at what templates it's using. There may be some inefficiency there potentially, although arguably you shouldn't be looking there firstly. And even signals. It's very important to remember that signals run within that response process. It's not some asynchronous thing. So if you have a post-save signal that's taking a while, it could actually be the villain that's slowing down your website. If you want to get really deep into stuff, there are various ways to profile Python. The one that I found the most useful is Django Extensions has a run profile server, which is basically run server that creates a C profile capture for every request. And you can give it a cache grind option, which will save it straight into a format that's compatible with cache grind, which then lets you load this up and you can explore. And I found, even with a basic understanding of profiling, it's very quick to figure out if you have a specific profiling problem, where the problem lies. So now let's have a little bit more of a look at Django itself. Your typical Django request comes in through the web server, through your WSGI layer, initializes a request. I do apologize to any core devs if I've oversimplified this. I think it's actually a reasonably good sort of coverage. Basically, if you look at Django's base handler, it does this. URL resolution, then you're hitting these bottom layers of middleware, goes through your view, and your template rendering. This is a typical situation, hitting one or more or none in terms of backend services before going back out through the outbound middleware that apply. So template response and response middleware. So it's good to keep that in mind when you are profiling where things might go wrong. And usually it's these bottom three things here. Up the top, Django is used and, used by a lot of people. That stuff is probably as performant as it's going to get unless you really want to really dig into it. So priority number one, or certainly option number one, if it's not the priority, is to look at caching. You can get some easy wins. You might not even have to optimize that weird SQL query. If it's something that happens on your homepage, and everyone gets the same one. You can cache that at various levels. The main thing to be careful of here, in fact, Tom's talk yesterday was really good about this. He talked about all sorts of caching and headers and various ways you can do that. E-tags, expires headers, all that sort of stuff is relevant, not only at the static resource level, but also for dynamic content. And I've got a list here. Basically, my recommendation is to read and know the caching documentation on the Django project website. It's really good. And here's just the visual representation of it. In one sense, I like to put this up here because sometimes you can avoid the request even hitting the browser. If you have a static resource, or effectively a static resource that's coming out of your Django application, you can tell browsers this isn't going to change, and it will never even come back and ask for it again. Then compression's another factor. I talked about this earlier with the static resources. The same pretty much applies with your dynamic stuff. There is a gzip middleware option here in Django itself. I feel that it's not the job of your application server to be doing that. It's busy doing everything else, and your web server, it's there for a reason. Give it that job to do. Some really basic stuff about query performance. If you are hitting certain query issues, again, that debug toolbar will show you where you're doing n+1 queries for things, where you're iterating over lists and creating an SQL for each one, where you're perhaps checking for the existence of something, and then you're going and fetching it again in a separate query set. Those sorts of things can catch you out. So select related and prefetch related, which is since 1.5, I think, 1.4. It's available now anyway. That will fetch your collections for you. So if you are doing a list of something attached to an object, you can make sure that you get those as well. Finally, again, going back to that idea of a signal that might be running slowly, you can defer workloads. So in your views or your signals, or if you're getting fancy with middleware, there may be some work that it's doing that actually doesn't affect the user whatsoever. And it's really simple using things like Celery, for example. Say you're running a swimming club, and your users have logged in, and you need to upload to the National Swimming Association some information. You can delay that work because the user doesn't need to know about it. Okay, so I've touched on a little bit of performance issues that you can cover with the back end, and I'm guessing most seasoned Django developers are familiar with that. I started digging around a little bit and looking at how Django works a little bit more underneath the covers. And basically, one thing I found quite interesting is Django basically does all of its work. It goes through that whole loop, and then it responds with a big payload, that string that is the response. And you can see in the timing metrics here, the back end does its work, and this is running on my desktop, so the response time is quick. The response then just flies back out. So that time to first byte, and which is really the first opportunity the browser gets to do anything, is delayed by all of the work that gets done through the views and all the middleware. So things we can do about that. There is a streaming HTTP response in Django 1.5 and onwards. It's designed for things like if you're streaming, say, CSV files back and you want to keep giving it out to the user as you're continuing to query it out of the database. And I thought, well, why don't we apply this to our templates? We could actually render any response in a streaming manner. It's just a generator as opposed to a string. It turns out that someone else had that same idea, and they wrote a pretty good patch that adds template streaming to Django. I've cleaned that up and put it into the ticket, which I'm hoping to get put in soon, which would actually allow for any template response to be streamed. There are some caveats there. Your middleware layers might not expect a generator instead of a string, so if you're looking at response.content, it's going to blow up on you. If an exception handles in the midst of streaming, you can't just suddenly throw a HTTP exception type response. You've already sent stuff back, so how you handle that's a bit tricky. And arguably, you're not going to need this. If your site's that slow that you need to stream stuff back, you're probably solving the wrong problem. But if this can be solved in a neat way, it might be something that actually is useful to everybody by default, and we can scrape a little bit of performance improvement for everybody. And then I got a bit more crazy, and I thought, what about eager streaming? And I came up with this little view middleware that basically shortcuts hitting the view function, and it actually streams back the top of a web page, ideally a static piece of the web page, before even calling the view function. So the web browser's already received something to chew on, like some CSS files to download, maybe some images, before we've even called our view function. I put this into a little proof of concept, and it does make use of both the timing tweaks in the debug toolbar and the streaming template stuff, so you're going to need a couple of other bits if you want to run it. But basically the way that worked out is, and I admit this is a very contrived example, it deliberately builds 1 second delays all over the place. Instead of having 4 seconds and then sending back the payload, you can actually send back some streaming content which will bring forward the request for that CSS, or the eager streaming, which sends back the header before even calling the view. And admittedly, my view had a 1 second delay in it, which is just to prove that this happens. Means that the browser is actually requesting CSS while you're still doing work. So I think that's an interesting idea. And in some respects, this might be enough just to fake performance for users. This is a bit hard to see, but the top one is the eager streaming, and it's actually got the top banner of the page back in half a second. I think there's another delay that I put in before that. The streaming version you can see is rendered. The original one, which does all the work first, is way back towards the edge of the room over there somewhere. So I thought that was an interesting idea. In terms of future context, this came up repeatedly yesterday from the keynote onwards. The future is not exactly clear in terms of web application development. There's APIs, there's WebSockets, there's lots more JavaScript. How this impacts on all of this isn't clear. It might be that we need to be focusing our attentions on writing performant APIs. Things like Speedy Protocol, I looked into this a bit more. For now, it doesn't seem to have a particularly clear impact. Basically, you get security and you get better TCP level performance, but it doesn't affect your actual application in a material way at the moment. Things like mobile, I touched on it. It's a whole crazy kettle of fish in terms of what's happening there as well. And as I alluded to earlier, that idea of full stack ownership, or at least somebody in your team noticing and taking care of that whole application performance side of things, is very important. So to sum up, measure everything. Measure, measure, measure. Don't fix something you haven't proven is bad first. Don't ignore the front end. There is diminishing returns potentially. As you start eking out more and more performance, you will get less and less little gains as you go. And finally, the technology is changing, so we all need to be mindful of that as we go forward. As promised, there are a couple of resources there which will go onto the SlideShare site. And I have a few minutes for questions. Thank you.
Okay, so we'll take questions at the 2 microphones and try to alternate between them. Please come and queue at the bottom of the stairs.
Hi, you mentioned Django Debug Toolbar a bunch of times, and I just was wondering, I love Django Debug Toolbar, but I ended up turning it off pretty early on in development because the act of using it slows everything down a lot. So I thought it might be worth just pointing out that if your site seems slow, try it with debug off and the toolbar off, and make sure that that matches what you're expecting as well.
That's a very good statement question. And I agree, I should point that out. In particular, the templates panel can blow up on older versions of Django and possibly even newer ones. And the profiling one tends to run things twice. So both of those can throw you for 6. And you're right, really if you're looking at this, you should turn it on when you want it. And then off for the rest of your development. Certainly there's cycles of development where you might want to not let it get in the way.
The idea of caching the headers and having that come first is really interesting. The problem with that is that if there's an exception or something that happens during the transaction, you suddenly want to abort it and return a 404 or a 301 or something. How do you solve that problem?
That was one of the points on that slide, is that if there is an exception, your best bet, you'll be able to spit out a bit of HTML that says, well, hang on, we've got to stop now. And really, that's where the you ain't going to need it part comes up as well. Maybe you should actually be writing your single page app kind of idea where the outside of your page is static, and instead of doing full HTTP requests, you're doing AJAX calls for pieces of the page or that sort of thing. And then you can properly handle exceptions because you're not doing this bit of acrobatics with the request.
Throw one more in here. Okay, so Django Core Dev here, time for ponies. And a comment from someone who obviously has, or a question from someone who has obviously paid a lot of attention to this full stack picture. Django gets slagged occasionally as being too heavyweight, too big, too complex. In your experience, is that actually, is there an area in Django's core that actually could do with tuning that is worth further analysis? Beyond obviously the tickets you've got in review that you want someone to take a look at.
In my experience, there's nothing particularly slow. If there's a problem with the ORM layer, it's usually well known. Or if there's a problem with template rendering, then it's well known and it might be a little bit acknowledged, and in some cases it might be overblown. In my personal experience, I haven't found any of it to be a problem. Partly because you have caching at your disposal, and quite often that's a good way around things. You know, if this chunk of template takes a while to render and it's always the same, you can cache it. If it's not and you're still getting performance problems, admittedly I haven't run into it, but there's other ways around that as well.
So Django debug toolbar renders HTML to the screen.
Yep.
But that's no good if you're using an API or an AJAX request. Is there something that maybe renders it to a file, or is there, what do you do? If you want it because you like Django debug toolbar but you want to use it on an API or an AJAX request?
I guess it depends which bits of the toolbar you want. So if you want timing, then your statsd or even just logging, if you're doing individual requests, will give you that information.
Yeah.
Similarly with your queries, I mean, you're never going to get nice, pretty waterfall graphs without HTML.
Just wondering if there's some way you can pipe that to another web server or something. That would be
there
nice,
might be something coming in Django debug toolbar, and I could be completely wrong, where it will actually record all that information and hang on to it, and then in a separate request you can ask for it. I don't know what the status of that is, but that would be the one way to look at it.
Okay.
Still got some more time for questions if you want to come to the microphones. I'll use my privileges to ask a question. To what extent can these performance measuring and reporting strategies for Django be part of an automated integration testing and reporting system? How much would you do that? What are the pitfalls?
One way you could do that is webpagetest.org as a website is quite useful. It also is open source, so you can download it, install your own instance of it, and perhaps as part of your integration testing stage, do some of that waterfall diagram type of stuff. And it has an API as well, as just command line tools and all sorts of things. So that sort of thing. In addition, there are other performance and load testing tools around there that aren't so much about the waterfall that comes out of a web request, but I'd say webpagetest.org might be something that could be fit into that, and it's not even Django specific really.
Okay then, so thank you very much, Rod. Yes, Roger, sorry.